There they come, trickling in. All right. Well, good morning. I've got Manny and Alex now. Good to see you. David and Natalie. All right, see if they by in a moment. Funnily enough, we're dealing with maps yesterday. And as I mentioned, I totally randomized my quotes. And it just so happened that the one chosen for today is the only quote I have that mentions maps, cartography. I don't know how that occurred, but yeah. It's late. Oh, hey, Natalie's here. All right. Excellent. All right. If you were paying close attention, you would have noticed that I changed today's topic at the last minute. Because I've been getting a lot of questions, seeing a lot of students run into problems with this topographical map thing from yesterday. And I figured, you know what? Let's go back, revisit it, and hammer that down smooth. Because it's been bothering me. It's clearly been bothering you, in that you're struggling with it and having problems. And oops. It's been making me mad, honestly. All of your questions have been frustrating me. Not with you. I'm not mad at you for asking questions. I'm mad at whoever failed to teach you how to read a map. Because I thought, clearly I was mistaken, right? I thought, hey, everybody's seen a map before, you know how maps work. What I'm going to add here is the topographical part. Not everybody has dealt with those. I thought that would be the new thing. And so when we went through this example, when you were already told the distance between the points from A to A prime is half a mile. Okay. Took a little while to do the unit conversion. All right, fair. All right, it's been a while. Unit conversion is a bit of a lengthy process, especially going from miles to meters, if you don't have that one memorized. All right, that took a while. But then once you got those numbers, it was very straightforward. We calculated the difference in height to the top of Wildcat Mountain already. So we take the height, we take the horizontal distance. Presto, we've got a slope, right? Rise over run. I thought that should have been easy. I thought the rest of this worksheet then would have been relatively easy. You read the map a little bit, that takes you a couple minutes to get your numbers, and then you're just dividing from slope. If I had given you, let me go back to some blank space here. And I'm gonna steal these numbers. We're gonna say this is 3168 and 27. If I had given you this picture and said, these are the units, right? These are the distances between my x1 and x2, and these are the distance between y1 and y2. You would have been able to find that slope no problem. So my plan was to introduce slope in a new context, to make it a little more interesting. We got to do some more slope practice. Hey, here's a fancy new kind of problem. Topographical map. So I figured it would be neat. Did not expect the sheer amount of panic and frustration to ensue because someone has failed. And it makes me mad and it makes me sad. Right? That you have not already learned how to read a map here. So let's go over that part of it. Right? The part that I've gotten the most issue with is, hey, wait a minute, how do I find this distance? How do I use the map key and the map scale? What is, this box has confused the heck out of more students than any box in geometry class ever did. Okay? This is the map scale.
Why is it like that?
Why is it like that? Well, part of it you gotta remember this should be like a perfectly straight line. I hope we've seen computerized digital lines. We can interpret the pixels there. That's not what's throwing us off. What's throwing us off is the fact that it looks like a rectangle that's divided in half, and then half of that is divided in half again. And it's like, why is it this weird, funny rectangle in a rectangle shape? Well, look at what map scales look like. I'm just trying. You'll see a lot of this. Right? These boxes within boxes. It's designed to enhance visibility. Right? Maps like to have colors on them. So when you see this black and white checkered box, it stands out. It's like a checkered flag at the racetrack. It's made to be highly visible. It's also made to be easily divisible. Okay? You can break it down into smaller pieces. By giving you that box and saying this whole length is 200 miles, and you can use this much of the box to represent 150 miles, this much of the box is 100, you can see those smaller and smaller increments. It's designed to make it easy for you to determine those.
My bad, I was in Discord. I didn't see the online.
Ah, okay. All right. Well, we're glad you made it. Let me update the attendance here. There we go. All right, so it's designed to be broken down. So let's look at our map again. The whole rectangle is 0.2 miles. And then they very conveniently show you already, oh, here is the halfway mark. So you have something to measure on that would be half of that, 0.1 miles. Right? So what I did, because I'm using Notability and I can draw on top of this, is I drew a line that length. And then I used my fancy cut paste tool and copy, paste, and then I can move this line around and I can say, okay, from here to there, right, is 0.2 miles. That's what I did, because that's the tools I had available. It also leaves something on the page for you to see later. But how would you do this at home? Any way you like. If you print it out, you put it out, or you could still do it on screen, doesn't matter. But you take something and you line it up. You take a piece of string, okay? And you hold it up to the scale and I get the whole thing on the board here. You guys know. Okay. My scale is right here, so I take like a piece of string or something, I hold it across and say, okay, that's 0.2 miles. And then I lay it down here, and that's 0.2 miles, that's another 0.2 miles, that's another 0.2. Oh, 3 lengths of string that are this length, so it's 3 times that. Okay. Or you use a ruler, your pencil, right, or thumbs. You can zoom out and hold your thumb. Okay, and it's 1, 2, 3 hand widths, right? Count with something, measure with anything, and compare that to the map scale. That's the part of the thing. Apparently, a lot of people never got taught. Nobody ever showed them this. At this day and age, you just pull it up on Google Maps, and it just tells you 5.7 mile drive to here. And you don't ever pay attention to that. Look next time in the corner, it's on Google Maps. Right? The map scale is there. Probably, really? Let's see, it's one of these. Images happen to be Google Maps. Oh, that's Maps, yeah. See, it's still there. Even when you click that zoom button and zoom in, that scale in the corner is going to adjust as you go. And I'll tell you, this much of the screen represents this many miles. So that on this map, even digitally, no matter how far I zoom in or out, the whole thing zooms proportionally so that that scale still represents the same amount of distance on the map. And that's what you use to count. So on this map, it turned out that from A to A prime was 3 of those full 0.2 mile rectangles. From B to B prime, it was only 1. So that gets you your horizontal distance. And from there, it's counting contour lines. Each line is 10 feet, so you take your contour lines from A to A prime, there were 27 of them, times 10 feet each, 270 feet up. Okay. By my count, it looked like B was actually slightly shorter. I got only 260 feet, found only 26 lines from one to the other. And they were kind of cramped. I'll totally honest with you, right? So this is where you have to think a little bit creatively. Right? Going straight across, they're going to blur on top of each other. It's really hard to read. But remember, the contour line is a continuous curve that represents the exact same elevation. It doesn't matter where you do your counting. And in fact, it doesn't matter the path you take. So I looked around this way, where the lines are a little bit farther apart, so I could see them and I could count them easier. I used those bold lines as a reference. Those are done every 5, so I could count by 5s. Okay, from here to there, 5, 10, 15, 20, and then 3 more. And then 3 more up here.
Why don't they teach this in school?
I have no idea. I was trying to think, like, okay, when did I ever learn basic map reading in school? I don't know, maybe sometime in elementary, grade school, maybe. Simple like simplified map of a city plan and learn about the scales on maps. I can see that being elementary or even middle school. It is geometry related, dealing with size and scale and space measurement. That's absolutely in the realm of geometry. So maybe now that I have this in mind, I might have to add that to my lesson plans for high school geometry. Okay? Just to make sure everybody's same page. This is an important skill you should have just in life, being able to read a freaking map. Come on. What do you do when your phone dies? Oh, I'm lost. Terrible. Oh, I gotta die. No, get a paper map. Okay? Everybody should have, if you don't already, okay? In addition to forget the math stuff, lifetime, okay? Go get a paper map. Go to, at this point, probably drive north, fine, take the highway, okay? Get off the...
But maps aren't like this. Maps show you roads and stuff.
Well, yeah, a road map. Yeah, not this one. But like, go to the rest stop close to the state border, okay? And you can get a free Illinois state map and keep that in your glove box at all times. Okay? Standard kind of thing that you should know, right? In addition to the ice scraper. Have that in your car all the time.
Well, did you not have one in your car?
Oh, I've got more than that in my car. I've got a whole list of the emergency equipment I keep in my car. Minimum. Yeah. I've got those emergency glass breaker hammers.
And the seatbelt.
Right? Yeah. Yep. So I come prepared. All right. Anyway, so that's reading the map scale. The height, again, is just counting lines, which means when you get to the second map, that last question, slope from C to C prime, are there any lines crossed taking that path? No. So does the elevation change at all? No. So if your change in height is 0, your slope would then be 0. Right. That one's pretty straightforward. The horizontal distance for D to D prime, here again, I have copied over those lengths of that rectangle. So I've got my blue line here, and wait, just remember, I've got a laser pointer. Yeah, okay, so I've got my blue line here, and I copied that, and that was most of the way. Not quite. I said, okay, how about let's use just the half. Maybe it's a 1.5. So I put the half segment over there. And it looks like it's about half of the half to get the rest of the distance. So we would call that a quarter, which is why I multiplied by 1.25 times 0.2 miles, 1.25 distance. Get my feet and then final slope. Okay? And then here is the math question. Hey, if you're going backwards from the same 2 points, which just reverse, you should have the opposite slope, the negative version, right? Same values, you just, what order you subtract them in, you just swap them and get the negative sign.
Makes more sense now.
And he says it makes more sense. Zoom people, how you feeling now? Does it look better? Any remaining questions on how this works? Okay. So, what can we learn from this debacle? One, I've learned that I can't assume too much about esoteric things that I would expect you to know. Okay? So I'll try to be more careful of that in the future. However, on your end. Okay? You need to be prepared to take things you already know, like slope. You can calculate regular slope of a line until the cows come home, no problem. And translate that into a completely new context. Because that's what calculus is going to be like. That's the experience. It's going to feel a lot like this. Like, okay, I feel like I got the slope thing, but now we moved it over here and I'm totally lost. So that feeling right there that you had yesterday of not understanding, I mean, like, I thought I had it and then suddenly I didn't. You're going to encounter that in calculus a lot. And it's not even because we go to real world problems. It's just the suddenly new layer of mathematics involved. And you feel like you fall behind. Okay. It happened to me. But, Calc 1 actually wasn't too bad. It was more Calc 2 and 3, right? All started getting screwy. So be ready for that. And then you have to make a concerted effort. Some of you reached out, you asked a lot of questions. I tried to answer them. And for some of you that helped. Other people just went, I tried my best, I'm still confused. I'm happy for that feedback. Thank you for letting me know. Do not just sit there in silence. It's always better to communicate with your teacher because it turns into, hey, let's take another day on this. We have plenty of time. But I want you to be more prepared to do your own research. Okay? Which is why I rewrote the classwork post as I did for today. Okay. Do more research. I even added a link. Here's a website, okay, where they break it down for you. This is a big deal in earth science. I don't know if anybody took the earth science class or is taking, but I don't remember what year that's on. That's junior year? Okay. So maybe some of you took that class. I don't know if this is covered there. You should find out. Right? They use a different term here, gradient. That's, if you look at their description of it, gradient, grade, incline, and pitch, used interchangeably with slope. Oh, okay. So now I know in the rest of the article, every time they say gradient, that just means slope. You know what slope is. Gradient is another word for the same thing. In my experience, it seems math class always uses slope, and then everybody outside of the math world likes to use gradient. Okay? Bunch of earth science resources come up, they use gradient. Physics uses gradient a lot. So everybody likes the word gradient. I don't know why. There you go. Another word for slope. That's all it is. And they give you some examples here. They fully explain it. Here's the topographical map. Point from A to B. Rise over run. They're changing the slope into a percent. Just times 100. And, oh, hey, look. We even have the arctangent bit here, right, that I mentioned before. So you can get an idea of the actual angle for that slope. Okay? So this is a great resource. I found it by Googling. Okay? How to find slope on topographical map. This came up. You can read through it. All right? Especially now with the online thing, you have to become a more independent student. Okay? I don't not ask questions. I still encourage you to ask me questions. That's fine. But there's some cases where really if you just looked something up real quick yourself, maybe you could have gotten it. Pull this up and read through that. Oh, it's right there. Oh, now I get it. Because they did present it a different way than I do. Right? We have the internet. Let's make use of it. Okay? This quarter, our actual math topics covered, it's fairly brief. It's really review stuff of like algebra 2, slope goes back to algebra 1, really. Right? Even middle school, even for some people. Yeah. So you should be intimately familiar with that. That isn't the difficult part. And if all we did was, okay, here's some more slope of line questions to do, it'd be boring as heck, right? And even if you find it more relaxing, you'd want that, like, hey, boring sounds great, that sounds easy. It is not beneficial for your brain. Okay? I want you to be engaged in something more challenging, push you to think deeper. That's what this exercise was about. So yes, we're going to see more tough stuff like this year. Because I need to toughen you up for calculus. And now this has turned just into a rant at this point.
So we take calculus our first year of college?
Should you?
Are we?
The plan is for you to be ready to do that, yes. Whether or not that is what you are going to do depends entirely on what field you're going into, what college you're going to, what their program looks like. Some of them don't always start you out with a college class.
So don't
Not
you
a-
take like Gen E, like where you have to take math and stuff.
Right, yeah. Most of the time, you're going to have to cover some basic math credits. Even if you're going into full-on English, I'm just getting, my story writing degree and write fiction and write stories and totally no numbers involved. Except you got to number the chapters as you go. You should at least be able to count, right? Okay. Anyways, yeah, even those general requirements usually at least some math class credit. And the bottom tier course that is usually worth credit, the first rung, is a first level calculus. That's why there's an AP calculus that you can take in high school. There's not an AP algebra, right? Because few colleges really grant real credit for taking an algebra course. Okay?
Do you take algebra courses?
I mean, some of them do, yeah, but they don't count. They would just be purely elective, right? Like they might even be, it might be required that you have done algebra before taking the calc course, which from your high school transcript, they usually let you skip that, right? But if it shows you haven't shown that proficiency, they might make you take that, but it doesn't give you any credit hours towards your degree, right? And that's Dr. O's big concern, is making sure everybody doesn't have to take those remedial classes that don't give credit. Because you still have to pay for them. And so it's literally a waste of money. In a sense that you're spending time relearning this stuff that you should have gotten here in high school. You don't want to do that. All right. I think I've babbled long enough. So redo yesterday's slopes if you have to, okay? I've already shown my answers. I'm not going to post them. You can scrub back through the video if you have to, okay? But it's all there. Showed it once. I'm going to make you work for it if you want it again. And then there is another map. Just one more map. Two slopes, one from A to B, one from X to Y. Same process. Contour interval, there is 100 feet this time. Your scale looks different. I don't know if I can get this on our screen here. Here we go. I have to hold it lifted. Right? Your scale looks a little different. But this should be more familiar. It's literally a ruler. Okay, so match it up with a real world ruler or a string. Take a piece of string or your pencil. Right? Hold your pencil. Put one tip at A. Move your thumb along your pencil until your thumb is at B. Now, without letting go of that thumb on your pencil, move the pencil to the ruler at the bottom. Put the tip on 0, and where does your thumb line up? That's how many miles it is from A to B, right? That's one of 1,000 methods. Figure something out that works for you. Don't care how you do it, you just need to measure the distance between A and B. Right? Okay. Are there any remaining questions? Right then. You've got the rest of the period to work on that. I think we'll move the Desmos activity I was going to do today. We'll just do that online tomorrow. And that'll be our class activity. We'll drop the rest of the stuff that I had for Friday. I think the Desmos is more interesting.
More fun.
What's that?
You said it's more fun.
It's more fun? Yeah, see? It's a Friday. We got to have the fun option.
It's the restaurant, it's
Yeah. What's not loading? The picture?
Yeah.
I literally opened it up on here from the classroom. So I know it's successfully attached there. Then you reload your whole page.
Oh, I got it. I just moved it and I threw the window.
Oh, yeah.
At what age did you start thinking back?
That's a tough one. I don't know, pretty early on. The animated series was about a little kid, so maybe I had action figures back when I was like four or five, so somewhere in there.
So your parents influenced your kind
I suppose. I mean, I didn't exclusively have Batman figures, so yeah, a variety of things. I had a Spider-Man figure too, which was really good because he had more joints, so he was a little bit more action posable. So I really liked that figure, but I never got into liking Spider-Man more. I don't know. What do you think of my mask this week? It's more what you'd expect.
of
You like my mask better this week?
yeah, last week it was like falling off me.
It was. It just, I got it to fit tightly, but then as soon as they start moving your mouth, it starts to fall down.
I don't like these type of masks. And that's Batman, right?
Yeah. So it's supposed to be like part of his mask. It looks great with my
You bought it
sunglasses.
online?
What's that?
You bought it online?
What's
Did
one?
you buy the mask online?
Oh, yes.
You should wear like little. Give them the
See, they match my sunglasses perfectly.
Does anyone ever turn to you in the car and they're like, oh, that's Batman?
I'm usually not wearing this
So,
in the car. 'Cause it's just me.
but your sunglasses.
I have gotten looks from the sunglasses. Those are a big hit.
If you like it, that's all I have.
Absolutely. vehicles, or could it stop the street in a while ago?
Right.